Hey everybody, welcome to another session. So today we are doing that I continuing on that IIT JEE 2023 exam paper, and today is section 3, and let's get to that section 3. So in this section we're going to have 6 problems, and they're all kind of one or two step problems. I think mostly two-step problems, where you have to combine two things or take 2 steps to get to the answer. A very big help is that this is not all the answers are non-negative integers. So if you got a negative integer or some fraction or something like that, it tells you that you made some mistake somewhere, or maybe the problem itself was incorrectly stated. Okay, it's possible. Some of the problems sometimes kind of can have an interpretation, equally valid interpretation that you put in, but that's not what was meant when they were setting up the problem. So you just need to go recheck it, and if you get a fraction, if you know the concept really well, and you should be very confident that your answer should be available through one of the interpretations of the problem. All right, because several people probably solved it just to make sure the problem was solvable in a short amount of time and made sense, at least from some reading of the problem. All right, so here you either get a full mark or you get 0. There's no negative marking. So looking at this this problem here, this is a very first problem. This is a problem in atomic physics. It's a very standard atomic physics problem. Okay, and so let's look at it. You have a hydrogen-like atom. But what is a hydrogen-like atom? So hydrogen-like atom is what's hydrogen atom? Hydrogen atom is 1 proton, and you have an electron. This is the Bohr model. Okay, so you have 1 electron. Hydrogen-like atom, instead of 1 proton over here, you have a Z protons, and you'll have some neutrons. Okay, plus some neutrons, but we're just looking at the charge part, but only 1 electron. And of course energy levels will have very similar formulas, because a Bohr model relies on this force between them, and this being a circular orbit and things like that. And you can also here is a circular orbit, and based on force between them and the angular momentum quantization, right? That the angular momentum, this electron in this motion, can only have integer multiple of some fundamental quantity, right? So you should know the derivation, but the final formula that comes out is it's like in this thing, energy level of the nth energy level. So energy levels are like, this is 0, and then all the levels are like this. So there is the lowest energy level, okay, and then there is a second one. So this, we'll call it n equals to 1, so n equals to 2, and then n equals to 3, then n equals to 4, and so on and so forth. And so this is if you look at this is energy, so this is 0, and these are all negative, So the formula for this you can compute using the Bohr model, which is equal to Z square over n square. That's what you really have to know for the energy part, and times what comes out here is minus 13.6 electron volt, and that's the same as in hydrogen atom. Hydrogen atom is Z equals to 1, so Z equal 1 for hydrogen atom, and you can see this is the lowest energy level value for hydrogen atom. So here so if you look at what's happening here, so n equals to 4, it says transition from n equals 4 to n equals 3, so there is this energy delta E. Delta E was E4 minus E1, so this energy came out as a photon. Now that photon is supposed to strike a metal, and it says a target metal. The maximum kinetic energy of the photon generator is this. So over here an electron comes out, okay, and this electron is it is just at the bound energy, right? So this, you have to know photoelectric effect. That's photoelectric effect, and you have to know the Bohr model to solve this problem, okay? So this energy has to be energy of this electron. So according to photoelectric effect, this energy has to equal work function of the metal, work function of this metal, okay, work function of this metal, and this kinetic energy of the as a result of this photon, kinetic energy of this electron that comes out, plus K max, okay. All right, so we have our working equation is E4 minus E1 equals to phi plus K max, and I think all of these are given in EV. So it says this question is telling us that let me okay, so let me get more space. All right, so this is telling us what the K max is. So K max is 1.9 electrons. So this is 1.95 electron volt. But for work function is saying that the threshold is 310 nanometers. So this is from the threshold. So 310 nanometer. What kind of energy does it carry? Well, Hc is this. So Hc over lambda will be the energy we want for this to get this converted into work function. So this will be the work function here. So lambda is given, and Hc is given to us 1240. This is something you have to remember. It's actually a good idea. Sometimes they don't give you. This is a very important. Hc equals to that, and lambda is given to 310, and this just very nicely taken to be 4. So this is 4 eV. So everything is in eV. So we know all of this on this side. On the other side, we have a z square minus 13 z square times minus 13.6 1 over 4 square minus 1 over 3 square, right? So now only thing not known is z square, and then I have to just work it out. And so okay, so I kind of worked out the numerical values from this, and I got z equals to 3. So I just took a square root, and this thing just comes out, and this whole thing, nasty looking thing, it just becomes 0.25 after taking a square root. and then this whole thing is 0.0625. So you can see that it's going to be 25 times 25 times 10 to the minus 4, right? And that's just 0.25, and that just quarter over 12 is 3, nicely is 3. Okay, so this I'll just enter the answer 3. That's the answer for question 8. All right, I'm going to do the next problem number 9, which is a nice optics problem here in the next video.